what's the point of just copying something? Isn't that a waste of time? And that is a totally fair question. The answer is where the real magic happens. See, the genius of an autoencoder isn't in making a perfect copy. It's all about a clever constraint we build right into the middle of the whole process. Look, if the goal was just a pixel for pixel perfect replica, the network wouldn't learn a thing. It would just be a fancy, expensive photocopier. The real learning, the good stuff, it happens in the struggle to reconstruct the original from that compressed summary. By forcing it to do this, we're actually forcing it to decide what information is truly important enough to keep. And that constraint has a name. It's called the bottleneck. We deliberately design this middle layer to be tiny, forcing all the rich information from the input through this narrow little opening. It's an information squeeze, and it means the network literally can't afford to remember trivial details. It has to learn how to identify and encode only the most essential, defining features of the data. This visual here just lays out the whole journey perfectly. Data comes in at full size. It gets squished down by the encoder layers until it hits that tiny bottleneck. That compressed code is what we call the latent representation. It's basically the machine's abstract idea of the input. And from that tiny code alone, the decoder then tries to rebuild the original, expanding the layers back out again. Now, maybe the most remarkable part of all of this is how it learns. This is a type of unsupervised learning. We don't need to give it any labels, no cat, no dog. The input image is its own answer key. The network has one goal: minimize something called reconstruction loss. In plain English, that just means make the output look as much like the input as you possibly can. This self-correcting loop is what makes autoencoders so incredibly powerful when you've just got mountains of unlabeled data.